Hi everybody, tonight we're going to talk about what does it mean to be in scientific notation. Remember, scientific notation is going to represent very large numbers or teeny tiny very small numbers. So keep that in mind as we figure out how we are actually going to represent it. First thing we want you to do is to pause the video and try to attack this problem. 1.4 times 10 to the third. Try to use what you know about exponents in order to do that. Here's a little hint for you. So go ahead, pause the video, and then give it a try. Okay, I'm glad you paused the video. Hopefully you tried it on your own. If we look at our decimal, 1.4, and we multiply that times 10 to the third, and we use what we know about exponents, we can first work out 10 to the third power. So what is 10 to the third power? 10 to the third power, oh, here's my pen, there we go, is 10 times 10 times 10. And we know that 10 times 10 times 10 is 1,000. So if I go ahead and I take 1.4 and I multiply it by 1,000, I should be getting 1,400 as my answer. Hopefully you got that as your answer. So now think about what we just did with exponents and apply that to what you're going to learn next. First thing I want you to do is I want you to go ahead and take a look at these numbers that I'm going to show you. And you're going to try to figure out what they have in common. We have 1.435 times 10 to the negative 7th, 5 times 10 to the third, 2.2 times 10 to the negative 4th, and 3.34 times 10 to the second. Pay close attention to both parts, the first factor and the exponent, and try to figure out what they have in common. Hopefully, on the one side, you're noticing that the first factor is always between 1 and less than 10. Look at our first factor. We have 1.435. Notice that's between 1 and less than 10. Look at the second factor. It's 5. Once again, between 1 and less than 10. The third factor is 2.2, which is between 1 and less than 10. And the last one, 3.34, is also between 1 and less than 10. Now if we look at the other side, at our exponent, hopefully you figured this out. The first factor is always being multiplied by an exponent with a base of 10. Notice that it doesn't matter what the exponents are. We have a negative 7, a 3, a negative 4, and a 2, but notice they always have 10 as their base. This means that these are all written in scientific notation. Now it's going to be your turn. Oh, sorry, no, it's not. First, we're going to summarize. Oh, sorry about that. A number is expressed in scientific notation when it is written as a product of a factor and a power of 10. Try to remember what the word product means. The word product means an answer when we multiply. And I'm just going to write that down in case you forget. So an answer when we multiply. Now, let's take a look at this. We have 6.378 times 10 to the negative second. Notice that we have a product of a factor, which is the 6.378, and a power of 10, which is 10 to the negative second. So remember, the factor being multiplied by the power of 10 must always be, always be between 1 and less than 10. And notice 6.378 is just that. It's between 1 and less than 10. And that is our first factor. Notice that our power of 10 has any exponent that you want to assign to it, just long as that base is always going to be 10. So let's try some. What I want you to do is state whether the following numbers are written in scientific notation, and if they're not, you need to explain why. Here are your numbers. So go ahead and pause the video, give it a try, write down whether they're in scientific notation or not, and if they're not, you have to tell us why. Hopefully you pause the video. So now we're back. So let's take a look at the first one. We have 4.0701 times 10 to the 7th. Ooh, look, yes, it is in scientific notation. And how do we know that? We know that because our first factor, which is right here, 4.0701, is between 1 and less than 10. And notice that it's being multiplied by an exponent with a base of 10. So it does satisfy both rules. Let's look at the second one. Hopefully you said no. The first factor, 18.432, is not between 1 and less than 10. So this is not written in scientific notation. Let's look at the third one. The third one is written in scientific notation. Notice our first factor is between 1 and less than 10, and it's being multiplied by an exponent with a base of 10. Notice it does not matter what that exponent is. It can be positive or negative, and it's still written in scientific notation. Let's look at the third one. Nope, the third one, or I'm sorry, that's the fourth one. I can't count today. Notice the fourth one is not in scientific notation. And we know this because the first factor, 0.0325, is not between 1 and less than 10. It's actually less than 1. So it doesn't satisfy that rule. Let's look at the last one. Ooh, a lot of you might have gotten tricked on this one because look at the first factor. It is between 1 and less than 10, 1.9 is, but look at our exponent. Notice that our base is not 10. Because our base is not 10, this is not written in scientific notation. I hope you got them all right. If not, you might want to go back in the video and just review. So here's your focus question for tonight. How do we know when a number is in scientific notation? Answer the question and make sure you bring it with you to class tomorrow. And remember, Mrs. Y and Mrs. Pearson are always better than Mr. U. Have a good day. Bye-bye. See you tomorrow. Please come to school.